Hello, this is Mr. Martin, and I'm out today, so I wanted to make a screencast concerning these redox reactions so that you wouldn't be a little shaky from last week, so it'd be a good refresher. And I'll go over some sample problems and then give you your homework assignment. Hopefully you brought your SPIC books today. Let's get started. So the first thing we should do is identify charges of each species or each element along the way, taking note too the charge of each compound, and note on all of these here it's all zero, so everything's balanced out. So this is barium chloride plus sodium sulfate gives us sodium chloride plus barium sulfate. So let's identify charges, and I'll kind of give some reasoning along the way. Let me change colors. All right. Here we go. So barium has a +2 charge. And how do I know that? Well, it's in column 2, which is alkali earth metals. All alkali earth metals have a +2. Chlorine is a halogen, and halogens have a -1. That's from your rule sheet. If you forgot those rules, please dig out that sheet and follow it. It's that half sheet. Sodium has a +1 charge because it's an alkali metal. It's in the first column. And sulfate, here we go. This is a polyatomic ion that we've had over and over that we need to identify and recognize as a -2. All right, so there we've done all the reactants. Now we go across the yield sign. Once we go across the yield sign, then we can be sure or identify what's really happening if there is in fact oxidation and reduction. So sodium here is still a +1 because there's only one chlorine. They haven't changed. So let's go on to barium. Barium has a +2 and this sulfate has a -2. So there's no change. There's no change. So for example, if I look at barium, barium has a +2 here and it has a +2 here. There's been no exchange of any electrons. That doesn't mean it's not a reaction. It just means that it's not a redox reaction. So when you have this case here, when no charges have changed, you can put no redox reaction. So we don't need to identify any oxidizing agent, reducing agent, what's being oxidized and what's being reduced. All that we need to do is just identify it's not a redox reaction and then move on. So try to remember that is something that could possibly come up. All right, we're going to try a second one and go a little bit further so that we can identify all those parts that I was just speaking about. All right, so let's go ahead and change back to our color. Here we go. So let's go ahead and get started. So here I have hydrogen and I have nitrogen. Hydrogen is a free element, and automatically, it being a free element, it has a 0 charge. Let me fix my color. Sorry about that. All right, so it has a 0 charge, and the reason why it has 0 charge is all free elements have a 0 charge. That's on that rule sheet as well. Nitrogen is also a free element, so it too has a 0 charge. Over here at ammonia, NH3, turns out nitrogen has a -3, and then for each hydrogen, it's a +1. Just following the rules, hydrogen's typically +1. There is some cases where it is a -1, but not here. All right, so let's go ahead and figure this out. All right, so if I go over here, and I'm going to trace the hydrogen to hydrogen. So look what happens here. So if I go from the hydrogen to this hydrogen here, it has gone from 0 to +1. It has increased its oxidation number. So if it has increased it, it has been oxidized. That one seems a little bit harder than the other. Let me do the other right now since we're sitting here. Let's go ahead and choose orange. All right, so let's go ahead and go from nitrogen. If I go from nitrogen here up to this nitrogen here, look what happens. It goes down by from 0 to -3. It has been reduced. And so I'll write that down. It's been reduced. What has been reduced? Well, nitrogen has been reduced. And why has it been reduced? Because it gained 3 electrons. All right, and then going back over here to the hydrogen, The hydrogen, it increases its oxidation number, so it has been oxidized. It has been oxidized, and the only reason why it has been oxidized because it lost one electron. So there's an exchange, and this is just a kind of a little precursor to what we're going to talk about tomorrow, but all you have to do today is identify those parts, and sometimes just outlining it that way is important. So I'll do this here. I'm going to label out what is our oxidizing agent, the OA, and remember, if it is the oxidizing agent, it'll have a reduced element, and then there is a reducing agent that we need to identify, and then what has been oxidized. All right, so then let me change colors so that we can identify. Okay, so the one that has been reduced, we said right here, reduced because it gained 3 electrons, its oxidation number has been reduced. So that would be the nitrogen, elemental nitrogen. And remember, you can put a 0 there. I tend not to because it's like an understood 0. But that's the element. The element has been reduced. So then that means the oxidizing agent is N2. The oxidizing agent gains electrons, the element becomes reduced. There it is. So that is something to kind of note, and we'll move on to the next. So then remember, I always start with the reduced because it makes sense. The oxidation number is going down. It's less than. It's going more negative. However you want to say it, but it becomes reduced. That means it's gaining electrons. That's the tricky part. By gaining electrons, it becomes more negative. It's not the opposite. We always think of something gaining that we want it to increase, but it's doing opposite here. We're gaining electrons because they are negative. Our oxidation number gets more negative. There we go. So then oxidizing is the opposite. It loses electrons, and in this case here, it is elemental hydrogen. And the reducing agent becomes H2. It is the compound and from which it comes from. And so once you have identified these 4 objects, these 4 things, you're finished with the problem, and then you're able to move on to the next. You'll have some practice today. I'll do one more just in case. Let me see, I have this one here. Carbon in water. Carbon in water. All right, so now let me go ahead and change. I think I'm in the red here, and I'll get started. First of all, identify the charges of each one, and you can kind of start to see what's going to happen. Most often, oxygen stays -2, so when you see it on both sides, you really don't see it changing. It's not going to change up its oxidation number. But let's take a look at everything else. So carbon here, carbon, since it is free, it is a 0. Let me change my color. I thought it was a different color. There it is. All right, so let's give this right there. Sorry. This is a 0. It's a free element. Let's identify. We said that oxygen is a -2, and then this hydrogen, for each hydrogen, it's a +1. Okay. Going across here, this oxygen still is a -2. That means that this carbon must be a +2. It has a 0. In order for these two to balance out, it must be a +2, and a -2. That's carbon monoxide. Carbon monoxide. Going over here to hydrogen, it's a free element, so it has a 0 charge. I just follow those rules, and away we go. Usually oxygen dictates what's happening. All right. So now that we have it all identified, I can outline my oxidizing agent, which will be reduced. Then I'm going to need to identify the reducing agent by identifying the oxidized element. Kind of work a little backwards, but it works. You got to find out what works for you. So I'll quickly go through this so that you can get started on your work. Starting with carbon. Carbon goes from a 0 to a +2. Look at that. So it increases. That means it has been oxidized. So I can put that here. I can start there. So carbon right there has been oxidized. And the reducing agent just so happens to be elemental carbon as well, because it's the reactant in this particular reaction. All right, let's go on to the next. Oxygen stays the same, But this hydrogen here goes from +1, reduces down to 0. It goes down to 0. So if it's going down, that means it's gaining electrons and its oxidation is reduced. So the reducing element in this case here is H plus 1. That's the element in water, and then the oxidizing agent would be the compound water. Well, there you have it. You identify each one, go through each and identify the charge of each element. Try not to use your oxidation sheet. Just try to use those simple rules that we've gone over, that we've given you on that little half sheet, and you should be fine. I'm going to put up your homework here. Here it is. It's in the SPIC book, page 220, number 4 through 7, and in the main text, page 522, number 1. Those problems should take you through the end of class. I hope to see you tomorrow, and we can start going over half reactions and discussing exactly how many electrons are involved. Thank you. Have a good day, guys.